This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on graphing cosine functions. Recall that the cosine is the x-coordinate, so at 0 degrees, cosine is 1, 90 degrees, cosine is 0, 180 degrees, cosine is negative 1, 270 degrees, cosine is 0, 360 degrees, cosine is 1. In trig, we prefer to use radians, so 0 degrees is 0 radians, 90 degrees is pi over 2 radians, 180 degrees is pi radians, 270 degrees is 3 pi over 2 radians, 360 degrees is 2 pi radians. So cos of 0 is 1, 0 radians, x value is 1. Cos of 90 degrees is cosine of pi over 2, x value is 0. Cos of 180, which is cos of pi radians, x value is negative 1. Cos of 270 degrees, or 3 pi over 2, x value is 0 here. And finally, cos of 360 degrees, cos of 2 pi, the x value is 1 again. So let's look at our chart. We have these values. If x is 0, cos is equal to 1, so that's a mistake. And here's the corrected version. Cos of 0 is 1, cos of pi over 2 is 0, cos of pi is negative 1, cos of 3 pi over 2 is 0, cos of 2 pi is 1. So let's go ahead and see what that looks like on the graph. So here are our 5 points. 0 is 1, pi over 2 is 0, pi is negative 1, 3 pi over 2 is 0, and 2 pi is 1. With that, we can then graph our cosine function, which will look like this. And indeed, we could zoom it in and see our primary period here from 0 to 2 pi. We could zoom it out a few times, and you'll recognize that that trend just continues over and over and over again. So this is our basic picture of cosine. So we want to kind of know that. Starts at 1, then 0, then negative 1, then 0, then 1. Here's our starting point. Here's our ending point. Starts and ends at the same point. The midpoint is on the opposite side of the curve, and the quarter points are at the midline. The quarter points here are at 0. Our next example is negative 4 times cosine x. So all we do is we multiply all of the cos x values by negative 4. So cos of 0 is 1. Multiply that by negative 4 gives me negative 4 cos x. 0 times 0 is 0, no change there. Cos of pi is negative 1, but negative 4 times negative 1 is positive 4. 0 times 0 is 0. Cos of 2 pi is 1. Multiply that by negative 4, and we get negative 4. This will be an upside down cosine graph, but we can see starting point, ending point, midpoint, quarter point. We see what those amplitudes have to be, so let's graph that. So here are our 4 points. 0 is at negative 4, pi is at positive 4, midpoint, 2 pi is back at negative 4, and then our quarter points here at pi over 2 and 3 pi over 2 are both at 0. So if we connect those up, we can see it's going to look like this, an upside down cosine function, because it was negative 4 cosine x. And connecting those values, we can see what that looks like. And again, I can zoom out and you can see that that pattern, repeats itself many times. You can also see that we still only construct one period between 0 and 2 pi. Since it was negative 4 cosine 1x, one period, one cycle between 0 and 2 pi. So our next example is negative 4 cos of x plus pi over 4 plus 2. We want to graph y equals negative 4 cos x. We've done that. That's our previous example. Then this x plus pi over 4 says shift everything to the left pi over 4, and this plus 2 says shift everything up by 2. So we'll take our last graph, shift it to the left pi over 4, shift it up by 2. We'll take those same 5 points, move them, and then construct our initial period. So we've taken all of our points and moved them just to show you that first point was down here. So minus pi over 4, that moves it back one box. One box is pi over 4. Up 2, from negative 4 to negative 2 is up 2. So we've gone ahead and taken every one of our points that we had before, moved it to the left pi over 4, and then moved it up 2. Now if we connect all these, we can see what that's going to look like. That's our fundamental period of this cosine function. So let's go ahead and graph that. Okay, so just to remind you of what that function was, it was negative 4 cos x plus pi over 4. We shifted it to the left pi over 4 plus 2. That's what we get. And then looking at our graph, you can see that that connects all of those points. And we could indeed zoom that out a few times, and you could see how that repeats itself. The primary cycle, though, is still contained in a range of 2 pi. The period of this function is still 2 pi. So our next graph is y equals 3 cosine of 6x. 3 is our amplitude. Fine, it'll go up to 3, down to negative 3. 6 is our multiplier. We need to create 6 cycles in 2 pi. So if there's 6 cycles in 2 pi, dividing 6 by 6, I get 1 cycle in 2 pi divided by 6. 2 pi divided by 6 is pi over 3. So the period of this function is pi over 3. Starting at 0, ending at pi over 3, we know that. We also need our midpoint and our 2 quarter points. Well, what's halfway between 0 and pi over 3? Well, the way to think of that is pi over 3 is 2 pi over 6. So halfway between 0 and 2 pi over 6 would be 1 pi over 6. So that's relatively easy to see. Now how do we get our quarter points? Halfway between 0 and pi over 6. Pi over 6 is 2 pi over 12. Halfway between 0 and 2 pi over 12 is 1 pi over 12. And then between the midpoint and the ending point, if this is what, 2 pi over 12, yes, and this is what, 4 pi over 12, what do we have? Oh, I guess that's not quite right. Let's rethink that. Okay, let's try that one more time. The midpoint is pi over 6, and the ending point is pi over 3. So what is 1/2 of pi over 6 plus pi over 3? So there's our corrected version. The midpoint is pi over 6, the ending point is pi over 3. I need the average of pi over 6 and pi over 3. Well, what is pi over 6 and pi over 3? Getting a common denominator, pi over 3 is 2 pi over 6. 2 pi over 6 plus 1 pi over 6 is 3 pi over 6. 1/2 of 3 pi over 6 is 3 pi over 12, which is also, of course, pi over 4. But I want Q1 and Q3 to have the same denominator just so we can focus on that concept. Now let's graph this by using our starting point 0, our ending point pi over 3, our midpoint pi over 6, and then our 2 quarter points pi over 12 and 3 pi over 12. Let's go ahead and graph that first cycle and see how that behaves. Of course, we know that our amplitude is 3. We're going to start up at 3, and we'll go ahead and use our amplitude to make sense of this. So let's think about a generic cosine function. The starting point 0 is 1. The first quarter is at 0. The midpoint at pi is -1. The next quarter is back at 0. And the ending point, 2 pi, is back at 1. But if I multiply by 3, what do I get, right? Up to 3, down to -3, back up to 3. That's the behavior of our cosine function. Now, where was our starting point, our midpoint, and our ending point? Well, our starting point was 0, and our ending point was pi over 3. So our midpoint was pi over 6. Now, if you count by pi over 12, you'll see how this is relatively easy to recognize. 0 pi over 12, 1 pi over 12, pi over 6 is 2 pi over 12. Q3 is 3 pi over 12, and then 4 pi over 12. Of course, 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. So those are my x values, and multiplying by 3 for my fundamental period, I'm going to get 3, 0, -3, 0, 3. So we're going to put all of these points in and graph those, and then connect them to get our fundamental period of this graph. So there are our 5 points, 3 cosine 6x. Now, we know that this should create 6 cycles between 0 and 2 pi. So if we would continue with this, we indeed should see that. Here it is. Let's count our cycles. There's pi over 12, 0. Pi over 6, or 2 pi over 12, -3. Pi over 4, or 3 pi over 12, 0. Pi over 3, 3. That is our first cycle. 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles, 6 cycles between 0 and 2 pi. Hence our cos 6x, our 3 cos 6x, gives me 6 cycles between 0 and 2 pi. Let's take a look at one more problem. Y equals 3 times the cosine of 6x minus pi, all minus 5. So what's going to happen here? We're going to go ahead and factor out that 6. So we get 6 times, if I factor a 6 out of pi, pi divided by 6 gives me that. 6 times pi over 6, of course, is pi, so we factored that correctly. So this is based off the same graph. This is based off of cos 6x. But I am shifting it to the right, pi over 6, and I'm shifting it down 5. So we're going to graph y equals 3 cos 6x, which we've done, and then shift that thing, pi over 6 to the right and 5 down. So I've got the thing I had before, same graph. So we complete the cycle between 0 and pi over 3, but I'm just focusing on that primary period. Now how do I have to shift this? Pi over 6 to the right and 5 down. So I'm going to take those points, subtract 5 over 6, add 5 over 6 to the x values and subtract 5 from the y values. So I'm shifting everything right pi over 6 and down 5. So I'm just going to show you those 5 points I had before. I'm shifting them to the right pi over 6. I'm going to do that first. So I shifted that to the right pi over 6. 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 Now I've got to subtract 5 from each one of those. So we're going to subtract 5 there, subtract 5 here, subtract 5 here, subtract 5 here, and subtract 5 here. So those should give me the 5 points we need to get our primary cycle. So here are those 5 points, our starting point, ending point, midpoint, quarter point, after we shifted to the right pi over 6 and down 5. And once we connect all those, that will give us the graph that we need. So let's envision that cosine function here, down, up, and down, continuing like that. And the function again is 3 cos 6x minus pi minus 5. When I graph that, you'll see all of those dots are connected. And we get our fundamental period, and that continues many, many times. And that will conclude this lesson.